This lesson is going to be broken up into much smaller pieces. Today we're going to talk about simplifying radicals and then multiplying radicals. So first, if we talk about simplifying, we want to simplify the square root of 12 c to the 6 d cubed. So to simplify this, we want to find a perfect square that goes into 12. Because if we look at it, we know 12 isn't a perfect square. So looking at our perfect squares, which they are, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, we want to figure out which of these perfect squares goes into 12 evenly. Well, I know 12 can be broken down into the square root of 4 and the square root of 3. 4 is a perfect square, so we can take the square root of that, and we're left with 2 square roots of 3. Now let's break apart the rest of it. We have the square root of c to the 6th and the square root of d to the 3rd. Now looking at this, remember, if we have the square root, that's the same as saying a 2 out in front. So we can divide the 6, c to the 6th, by 2. So doing this, we get c to the 6 divided by 2, which is 3. So c cubed. And now looking at the d, again we would take this 3 divided by 2. It's not evenly, but we can take 1d out, and we're left with the square root of d. Because this is the same as saying 1½ So we are left with, we can take 1d out, one full one out, and we're left with 1d under the radical still. So now if we want to simplify this and put it all together, we would have 2c cubed d times the square root of 3d. And that would be our simplified answer. Let's look at the next problem. The cube root of 27 y to the 12th z to the 7th. So again, let's break this up. We want to find the cube root of 27. We want to find the cube root of y to the 12th. And then the cube root of z to the 7th. So if we do this, the cube root of 27 is actually a perfect number. So that is 3 if you take the cube root of 27. Next, we have y to the 12th. Well, it's the same thing. If we have a 3 out in front, we can take our exponent and divide it by 3. So y to the 12th divided by 3 would leave us with y to the 4th. Now, our next one's a little bit trickier. The cube root of z to the 7th. Again, we want to see how many times 3 can go into 7. And it can go in twice. So we have at least z squared. And if it goes in twice, that would be 6. So with 7 minus 6 would leave us with 1 cube of z left. So we'd have the cube root of z left. So our answer would be 3 y to the 4th z squared times the cube root of z. That would be our final answer. The next topic we're going to talk about is multiplying radicals. So again, we're going to take it piece by piece. So up front we see we have a 6 in front of that one and a 4 in front of that one. And we need to multiply. So we're going to take 4 times 6, which gives us 24. Next, we're going to look at what's underneath the square root. We have 8 times 2. If we look across, we have an 8 and a 2. Multiplying those together, we get 16. Again, we keep looking. We have a c cubed and then just a plain c. Remember, when you multiply variables, you add exponents. So we would have c to the 3 plus 1, which is 4th. Next, I see we have a d. We have d in both of them. So, again, we add exponents. So we would have d to the 8th. And that is our combined radical. Now we need to continue to simplify it. So, looking at it, we want to take the square root of 16 c to the 4th d to the 8th. So we keep our 24 out front, and we take the square root of 16. Well, the square root of 16 is 4, And then, since we're taking the square root, remember there's always a 2 out in front. So we're going to have c to the 4th divided by 2. 4 divided by 2 is 2, so we're going to be left with c squared. It goes in perfectly to the radical. Same thing with d. We're going to take 8 divided by 2, and we are left with d to the 4th. So, continuing to simplify, we have 24 times 4, which can be simplified to 96. And then we have c squared d to the 4th. And that's our final answer. Again, we are asked to multiply these radicals. So we look for what number's out in front. I have a 2 and a 3. So 2 times 3 is 6. And then I have my 4th root. So once again, we're going to combine like terms. So we're going to multiply 8 times 2, which it gives me 16. X to the 3rd times x to the 5th. Remember, we add exponents, so we would have x to the 8th. And then we have y squared times y squared, which we would add again, giving us y to the 4th. So, simplifying this, we still have our 6 out front. The 4th root of 16 is actually even, and it comes out 2. We divide the 8 by 4 this time because it's our 4th root. So we would have x to the 2nd, or x squared. And then again, we would divide the y to the 4th by 4 because it's a 4th root of that. So we would be left with y to the 1st. Simplifying this, we get 6 times 2, which is 12. X squared, y to the 1st is the same as just saying y. So our simplified answer would be 12x squared y.